reading selection today is about Stephanie Kwolek, and she is an inventor. So let's talk about the genre. It is a biography. Biography can be broken down into two things. Do it with me. Bio and graphy, which we'll call that graph. So bio, graph, bio, biology. Bio means life. And I was thinking about the word biology because I've heard that you might have a brother or sister or somebody studying biology in high school. That's the study of life. So bio is going to be life. And graph means writing. So it's life writing. It's a writing about the life of Stephanie Kwolek. So if we wrote about her life, is that fiction, fake, or is it nonfiction? It's nonfiction. So this is true stuff. And let's take a look at the essential question again. How can inventions solve problems? So you're going to read how Stephanie Kwolek invented a super strong fiber that saves lives. And fiber is just normally like a string of some sort. There can be different types of fiber, but it's kind of like a long strand. So I know you think of string as like rope that you've seen, but strand means long and thin. So like a strand of hair, and you could have a strand of material. So she made some special she came up with a very special material that's long, and then she makes it go together somehow. So here we go. If you could invent a material for a superhero, what would it be like? It would have to be light, strong, bullet resistant, and fireproof, right? Chemist Stephanie Kwolek actually invented a material just like this. It's called Kevlar. Superheroes don't wear it, but everyday heroes like police officers and firefighters do. So do you see this little R right here? That stands for registered. That means that Kevlar is actually something that they sell. And that means that if they're making money off of it and she invented it, then it's a special material that not every company has. They have to buy it from her. Becoming a chemist. From the time she was young, Stephanie was interested in math and science. See, a biography, we're probably going to figure out what their life was like in the beginning, the middle, and near later in their life as well. She was not the kind of student who caused mischief. Remember, mischief is a little bit of annoying behavior. And she worked hard in school. Stephanie's teachers spotted her talent and talked to her about careers in science. With their encouragement, Stephanie studied chemistry in college. She had hoped to go on to medical school, but could not afford it. Consequently, that means like as a result, Stephanie took a job working at a textile lab. Now, textiles are materials and cloth and things like that. She planned to save up enough money from her job so that she could pay for medical school. At the lab, she discovered that she had a genuine love of chemistry. Remember this? Genuine. Yep, it's real. It's a real love of chemistry. She wasn't faking it. She learned how to make chain-like molecules called polymers that could be spun into fabrics and plastics. Stephanie enjoyed doing experiments so much that she decided not to go to medical school. So if she went to medical school, she'd be on a path to become a doctor, but she loved experiments, so she's going to follow her own path. A strange liquid. Let me move myself out of the way, people. In 1964, Stephanie's lab supervisor asked her to work on making a strong, stiff fiber. The United States was facing a possible gas shortage, and scientists wanted to help. They believed that if they could reinforce tires with a lightweight fiber rather than heavy steel wires, cars and airplanes would use less gasoline. So this needs a little bit of explanation. There are tires, and you know that they're made of rubber, the black tires. But inside the tire, there's some other types of fiber so that the tires will not wear down so fast. And back then, there used to be something called steel belted tires, and they had steel inside of them. But steel is a very heavy metal, so they're looking for something different to put in there. Stephanie began experimenting by mixing polymers. One day, she made an unusual solution or mixture. Polymer solutions are often thick, like molasses. Molasses is like a really thick syrup. However, this solution was cloudy and watery. Okay, and as a reminder, I do want you to follow along, so I'm reading right here. Oops, it's not in the right place. With Stephanie. Stephanie brought her strange liquid to the worker in charge of spinning liquids into fibers. He looked at Stephanie's solution and laughed. He thought it was hilarious. He thought it was hilarious that she believed it could be made into fiber. Sounds kind of like a rude person. It looked too much like water and might even clog the spinning machine. But Stephanie kept urging him. He's like, come on, dude, do it. Come on. That's urging. Kept urging him to spin it until he finally agreed. When he followed the procedure, when he followed this step by step, a strong fiber began to form. Stephanie's head spun. Why do you think it spun? And she felt dizzy with excitement. Oh, I think we got her answer. She was so excited that she was feeling a certain strange way. Okay, now, just as a text feature, we don't need to read this right away. We can come back to that. This is a timeline. So let's keep reading. We'll come back to the timeline a bit later. Stronger than steel. Come on, make a prediction here. What do you think is stronger than steel? It's the Kevlar. Can you see what I'm mouthing? Kevlar. Yeah, it's Kevlar, people. Her stuff is going to be stronger than steel. Stephanie tested the fiber in the lab and found that it was fireproof. That means it can't burn. It was stronger and lighter than steel, too. With these qualities, she believed that the fiber could be turned into a useful material. She was right. The material became known as Kevlar. After Stephanie's discovery, it took almost a decade of teamwork to develop Kevlar. Decade, decimal, DEC, right? I'm thinking of the prefix DEC. Decagon. Decagon has 10 sides. Decade has 10 years. I gave it away already. I thought I was going to go on to decimal. Decimal deals with tenths, right? All right, so 10 years here. That's a long time. That's why a lot of the cool stuff that we have today was developed a long time ago. And it takes like 10 years to come out. It took almost a decade of teamwork to develop Kevlar. So stay with me. We're down here. Let's see if I could get a pointer of sorts. Just a second. Do I have one? I don't know if I have a laser now. I don't. Do I? Well, here we are, right here. Okay. Close that up. Well, a little bit further down. Some people spent hours on the telephone with the patent office. Others had to think of a way to use and sell it. Nowadays, remember I said we talk about the present day, but we compare it to the past. So, nowadays, Kevlar is used by almost everyone. The president and other politicians wear protective clothing made from it, so it goes underneath their clothing. You can't see it. So do lumberjacks. Lumberjacks are people that cut down trees and work with saws, firefighters, and police officers. Kevlar is also used in tires, bicycles, spacecrafts, and skis. Sorry. Oh no. Pause. How do I pause? Am I recording? I think so. Okay, I'm back. Right here. Kevlar is also used in tires, bicycles, spacecraft, and skis. By developing Kevlar, Stephanie had found a way to make protective clothing and equipment that is both light and strong. Stephanie's invention has saved many lives over the years. She was inducted into the National Inventors Hall of Fame for her work. Inducted means she was brought in. And her photograph has appeared on a book cover and in advertisements for Kevlar. She says that she never expected to be an inventor, but is delighted that her work has helped so many people. Alrighty, so now we're going to answer some questions. And your first question is, let's remember back to the essential question, which was, how do inventions solve problems? So how do inventions solve how do they solve problems? So that means that they must have discovered, like, there was an issue, there was a problem out in the world, but it wasn't just one. There was a bunch of problems, and they said, why? We'll solve that problem by inventing Kevlar. All right. So I want to know, what problems did Stephanie's invention solve? Okay. You'll have to take some think time on that for sure. And what would you make out of Kevlar? And we want you to explain why and explain what it is. Okay, people. See you soon.